In this problem, we're dealing with the reaction with a diene and a dienophile, which basically consists of an alkene attached to an electron withdrawing group. And so this is going to be a Diels-Alder reaction. And the products of Diels-Alder reactions are cyclohexenes. And so it's a good idea to just go ahead and draw this reaction out. And go ahead and number 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then when transposing the starting materials onto this cartoon, what I like to do is I like to label the alkene on the diene as A and B. So there's A and B. A is a trans alkene, so that nitrogen is going to be heading that direction. B has the ethyl group off of carbon 3, so 1, 2, 3, 4, and so on and so forth. So it looks like that. Now 5 and 6 at the carbonyl, and then that's off of 6 and 5 as the ethyl group, and they're cis to each other. And now it's a matter of plugging these groups into our cyclohexene. I'll just redraw the cyclohexene real quick. 1 has a nitrogen with 2 methyl groups off of it. 3 has an ethyl group. I'm going to go ahead and draw that in because that's got to be a line because it's attached to the sp2 carbon. Carbon 6 has a carbonyl. Carbon 5 has an ethyl group. Now, let's double check to make sure that our electron donating group and electron withdrawing group are ortho or pair to each other. That's the ortho-pair rule. And so our donating group on the diene is the strongest one, is the nitrogen. And the electron withdrawing group in the dienophile is the carbonyl. And we look, they are on adjoining carbons. They are 1, 2 away from each other, and so therefore they are ortho, so that checks out. If they weren't, we would have to basically just switch those two groups. So now it's a matter of picking stereochemistry. Start by picking the stereochemistry of the electron withdrawing group. I'm going to choose it to be a wedge. And we look at the other groups on the dienophile. It has an ethyl group cis to that, so therefore that ethyl group is also a wedge. So that's cis stays cis, trans stays trans. And now when figuring out the stereochemistry of those two carbons, we use the endo-exo rule. Essentially, we take the outside groups, and the outside groups are these groups, and we make sure that they are cis to the electron withdrawing group. So nitrogen is an outside group, so we are going to make that a wedge. The inside groups are these groups right here. They're cis to the other alkene. They end up on the opposite face of the electron withdrawing groups. And so we get this product right here. And since it's chiral and we started out achiral, you get a racemic mixture. And so now it's just a deal of trying to figure out which one matches that particular structure. And then we see that it's A. C is the exo product. B has a problem of this, of here, they're trans and they're cis up here. D also has that issue as well. And is also an exo product.